Hello, this is a half-life problem where we're going to be figuring out how long will it take for only a certain number of kilograms or whatever of this thing to be left over. So there's a half-life. We are told that the half-life of a certain radioactive substance is 16 years. That means half of it will be gone in 16 years. So if we started with 100 kilograms, in 16 years 50 kilograms will be left, or whatever. So there is a formula figure out the rate. So in order to solve this problem about how long will it take to have 10 kilograms left, we need to first find the rate of decay. Okay, and there's a nice formula for that. The rate of decay, or the K value, is the natural log of 1/2, very similar to the doubling formula, only when you double you want natural log of 2. Here, the half-life, the natural log of 1/2 divided by the amount of years, or T. Time could be years, it could be days, depending on the substance. So if we take the natural log of 1/2 and divide it by 16 years, that will give us our rate. Sorry, bless me. I sneezed. So let's figure this out. Tools, let's bring up a calculator and see if we can have this done. The natural log of 1/2. So if I can figure out my natural log button here, don't know what this means, but this calculator is not very good at all. Let's bring up a better calculator. Good old handy TI 84. Waiting, here we go. Let's continue with the trial version. I accept anyway, sorry about this. There we go, calculator. So what we want to do is take the natural log of 1/2, close parentheses, and divide it by 16, the number of years. So when we do that, we get negative 0.0433 as our K value. Okay, we would expect it to be negative because it is decay after all, so things are getting less. So negative 0.0433 is our decay value. So now we go back to our equation. We had 60 to begin with. That's n sub 0, or p sub 0. When will there be 10? So that's our n value. So our equation looks like 10 equals 60 e to the negative 0.0433 times t. We want to figure out how long it will take. So time, not time for our half-life, but time for our formula. So our 3 steps are first to divide. So we divide both sides by 60. 10 divided by 60 is 0.1666667 equals e to the negative 0.0433 times t. Our second step is always to natural log both sides. So we natural log both sides, which eliminates this part. So we have the natural log of 0.16667, which I will do in a second, equals negative 0.0433. And our last step is to once again divide. Divide by negative 0.0433. Now let's go back to our calculator. The natural log of, well, it was 10 divided by 60. So don't round here, so I'll put in this whole entire value. 10 divided by 60 divided by negative 0.0433. From right here. So when I press enter, we should get a positive number. Years will always be in positive, and it looks like it's 41.4 years. So it will take this radioactive substance 41.4 years for there to be only 10 kilograms of our original 60 left over. Okay, so that's always how we do half-life problems. We find the rate of decay, and then we figure out what our percentage is left. That means there's 16.7% of our stuff left. So this is a percentage, this ratio of what we have to what we had. And then you take its natural log and you divide it by the rate, and that will give you the time it takes in years.